Okay, now let's go on to number 5. We have rectangular coordinates, and we want to convert it to polar coordinates. So this is x and y. So a good way to go from rectangular to polar is to use the relationship that x squared plus y squared is equal to r squared. X here is -3, so I have -3 squared plus 4 squared is r squared, which implies that r squared is 25, and we'll take the positive version. So r is 5. Okay. Now for the angle, we want to use this formula. Theta is inverse tangent of y over x. So here y is 4, x is -3. Plug this in, and you get 2.2143 as theta. So your answer is 5, 2.2143. So that's the polar coordinate. For number 6, let's do the same thing. X squared plus y squared equals r squared. So I have √3 squared plus -1 squared equals r squared. √3 squared is 3. -1 squared is 1. We get 4 is equal to r squared. So that means r is equal to 2. For theta, we're going to take the inverse tangent of y over x, which in our case, y is -1, x is √3. So you can use a unit circle here. So if you want to use a unit circle, how about that? We would write this in terms of -1/2 over √3 over 2. And the way you think about it is, okay, this is y over x. And inverse tangent, the range is between -pi/2 to pi/2. But you do not want to include -pi/2 and pi/2. So let's see, we have -1/2 for the y, and then x equals √3 over 2. So that clearly has to be in the fourth quadrant. So it turns out that's the 11 pi over 6. So that's theta. So together, this would just be 2, 11 pi over 6 for number 6. Okay, now let's go down to number 7. So we want to convert the rectangular equation. So we're given x and y to polar form in terms of r and theta. Assume a is positive. So here, let me just write these down. A is positive. The only one that has a is number 11. So just assume that this is positive. And we'll talk about it more when we get there. Okay, for 7, x squared plus y squared equals 9. We know that x squared plus y squared is r squared. That's one of the formulas we have to memorize. So this equation converts to r squared equals 9, which means r is equal to 3. So that's the form. For number 8, we're given y equals 4. So we know that y is equal to r sine theta, and that's equal to 4. So whenever we convert these equations into polar form, you always want to have r on one side and then everything else to the other. So right now, r sine theta equals 4 has sine theta with r. So let's move the sine theta to the other side by dividing it. And that's the same thing as 4 cosecant theta. So r is equal to 4 cosecant theta for this one. For number 9, we have 3x plus 5y minus 2 equals 0. So I'm going to make the substitution that x is equal to r cosine theta, y is equal to r sine theta. So plug it in. It's 3r cosine theta plus 5 sine theta minus 2 is equal to 0. So 3r cosine theta and 5r sine theta has r in common. So it's 3 cosine theta plus 5 sine theta. I'm going to throw the 2 to the other side. And now I can solve for r as 2 over 3 cosine theta plus 5 sine theta. Okay, number 10. I have my favorite equation, x squared plus y squared. So just put r squared for that. We're squaring that is equal to 9 times the quantity x squared minus y squared. And this one, I'm going to replace x and y with r cosine theta and r sine theta. Okay, so that implies that r squared is r to the fourth is equal to 9 times r squared cosine squared minus r squared sine squared. So we have r to the fourth, and both of these terms have r squared in common, so I'm going to pull that out. So I left with cosine squared minus sine squared. I can divide both sides by r squared. And here we're assuming that r is positive. And that makes sense because if r was 0, I'm sorry, we're assuming r is non-negative. I'm not non-zero. Because if r was 0, you would get nothing. So that doesn't make sense. Anyway, so let's divide by r squared. So if r squared is equal to 9 times the quantity cosine squared minus sine squared. I can take the square root of both sides. And actually, first let's do this. Cosine squared minus sine squared is a double angle formula, which is equivalent to cosine 2 theta. So this is just a fact from trigonometry. So one of the trigonometric identities. And actually, we won't take the square root. We'll just leave it as it is. This is perfectly acceptable. Okay, last one, number 11. I see here it's x squared plus y squared. So immediately you put r squared. And then we have 2a. X is r cosine theta. Okay, so here I want to solve for r. So it's a little tricky here. I can move the 2ar cosine theta to the other side. Again, we're going to assume r is not 0, because otherwise you get nothing. So you would have, let's divide by r. We have r equals 2a cosine theta. Yeah, so this is the right answer.